Like classes, components also can have ports. A port, which looks like a small square attached to the side of the component's classifier, lets you group related interfaces, both provided and required, when you attach those interfaces to a component. So when you want to show that a component's provided and required interfaces are related in some way, you would do it like this. You'd put a port on the side of the component classifier, and then when you draw your provided and required interfaces, you would connect both of those to the same port. Here we have two required interfaces connected to one port, and over here we have one provided and one required interface connected to the same port. When you have this situation where there are both provided and required interfaces connected to the same port, we call that port a bidirectional port. So to give an example, let's say our component here is a warehouse. And over here, these two required interfaces, let's say those are furniture delivery and appliance delivery. So those are two related required interfaces that connect through one port to the warehouse. Over here with this bidirectional port, we have one provided and one required interface. So let's say that the provided interface, which the warehouse implements, is shipping, and let's say the required interface is a rate calculator. So in this diagram, the use of ports gives you a little bit more information about the relationships of the interfaces to the component. These two kinds of delivery are interfaces that are related to each other and come into the component through the same port, and these two interfaces are also related. Now you can show the internal structure of a component, and here's an example. Showing the internal structure can be helpful when you want to show, for example, relationships that exist in a certain context. In this example, in our Order Manager component, we have a couple of classes that are associated with each other, Order List and Order. And as you can see, we have two ports with two interfaces, Data Source as a provided interface and Inventory Checker as a required interface. Now you can add some more information to this diagram. One of the reasons to use ports is that they let you map an interface to the classifier inside the component that implements its functionality. And you do this by using a symbol called a delegation connector, and that looks like this. It's a solid line with an open arrow. Now here's how delegation connectors work. Port is door in French. So in a component diagram, a port is like a door that lets in some communication from outside the component. And the delegation arrow points from the port to whatever part receives or passes on the communication, the arrow pointing in the direction of the communication. So these connectors show that some internal part of a component implements or uses an interface of the component. And again, just to emphasize, when you're using delegation connectors, if a classifier realizes or implements an interface, draw the delegation arrow from the port to the classifier that implements that interface. If, on the other hand, the part of the component uses the interface, you draw the delegation arrow from the part to the port that is connected to the interface that that part uses. So using ports and delegation arrows can help you to organize your diagrams, show relationships more clearly, and show the direction of communication from outside the component to the parts inside the component more clearly.